Welcome back. Problem 7-7. So statement is the shaft is supported by a smooth thrust bearing at A and smooth journal bearing at B. If P is 20 kilonewton, determine the absolute maximum shear stress in the shaft. So you can see this is the shaft, this is thrust bearing, and this is smooth journal bearing, and this is acted upon by load P at this point. So the this shaft is a hollow shaft having outer radius 0.04 meter. This is written, and inner radius is 0.03 meter, while this load is 20 kilonewton. So you have to find the maximum shearing stress in the shaft. So let's start with the solution. The first step is that you know that you have this bearing. So if you remove this bearing, so definitely there will be a vertical reaction. Let this is FA, clear, and this, if you remove this thrust journal bearing, so you will be have a reaction force. Let this is FB. So first we will find this FA and FB by using equation of equilibrium. So how you will find, I hope that you will be able to solve this, but I will solve it. Sum of all moment at point A is equal to 0, taking the counterclockwise moment as positive. So about point A, we have one force is this one, and the perpendicular distance is 1 meter, and that will produce counterclockwise movement. So I will write P, which is 20 kilonewton. So 20 into perpendicular distance is 1, and it is positive. The second moment that is due to this FB, and perpendicular distance is this one, and this is producing counterclockwise movement, so it will be also positive. So plus FB into perpendicular distance is 1. The third moment is due to this load P, and perpendicular distance is 2 meter, and it is producing clockwise, so it will be negative. So minus 2 into P, which is 20. Their sum must be equal to 0. So from here you will get FB will be equal to FB plus 20 minus 40 will be equal to 0. So FB will be again equal to 20 kilonewton. Now you have this FB, you can find FA as well by using sum of all forces along y direction must be equal to 0, and taking the upward force as positive. So minus P, which is minus 2P, plus FA plus FB, which is 20 kilonewton, is equal to 0. So minus 2 times P is 20, plus FA plus 20 is equal to 0. So minus 40 plus 20 plus FA is equal to 0. So from here you will get FA will also again equal to 20 kilonewton. So you have this FA is again equal to 20 kilonewton. Now we know that maximum shearing stress is equal to maximum shear force into Q divided by I into T. So we do not know V max. So how we will find? We will draw the shear force diagram for this. So I will draw vertical lines from the end of this, clear, and we will draw horizontal line to show the length of beam X in meter. So we will plot shear force here in kilonewton. This is your 0 point. Now at this point you can see you have P, which is downward minus 20. So let this point is minus 20 kilonewton. So minus 20 kilonewton. Now moving from these two till point A, so there is no other force, so it will remain same. So this shear force will remain same till this point, till 1 meter, clear. Now at A you have a force FA, which is plus 20. So minus 20 plus 20 will bring it to 0. So this will move to 0. Okay. Now again moving from point A to B, there is no other shear force, so it will remain same. So it will remain same till 1 meter. Okay. So let this is 1 meter, this is 2 meter. Now at this point you can see that there is a load of FB which is upward, and that is 20 kilonewton. So it will move upward. So it will move to this point because 2 division is 20. So this is plus 20 kilonewton, and it will again will be straight, and you can see there is a minus 20 which will bring it to down. Okay, so this is your shear force. Now the shear force diagram. Now from this shear force diagram, we know that maximum shear, absolute value of maximum shear stress, shear force is 20 kilonewton. So this is solved. We do not know Q, so we will solve it for it Q for hollow pipe. So let assume this is the hollow pipe. You have to draw it appropriate so that it can look like. So let's assume that this is the center line. Now if you see that if you have a solid shaft, clear, and this is its neutral axis, so we know that Q is equal to sum of y dash into area. So y dash for this semicircle that is above the neutral axis, it is represented as, it will be represented as y dash, and this y dash is equal to 4 over 3 pi into r. This is the formula. So what we will do is that we will consider this first, this as a solid, clear, and we will find the Q, first moment of inertia of this solid shaded semicircle, clear, and then we will subtract this solid shaded circle, and we will find Q for that as well. Then we will subtract the Q1. Q1 will be for this whole, clear, and Q2 will be for this one. So Q1 minus Q2 will be only for this portion, this pipe portion. So let's move and solve this. So this having outer radius is 0.04 meter, and this inner radius is 0.03 meter. So what will I do? We know that this is equal to y1 dash into a1 plus, here we will write it minus because we will subtract the larger from the smaller from the larger, and y2 dash into a2. Now if you assume this as a solid semicircle, clear, so definitely it will have a certain y dash is its centroid from the neutral axis, so it will be here. For example, if this is its vertical axis, clear, so this is y dash, this distance is y1 dash, and this y1 dash will be equal to 4 over 3 pi into r, and r for this outer is 0.04. Similarly, y2 dash, if you consider this as a solid, so definitely it will also have y2 dash centroidal axis from centroid from neutral axis. So let this is, I will choose another color, let this is your, this point is your centroidal axis, and this is your y2 dash, and that will be equal to 4 over 3 pi, and this for this r is 0.03. Now we will move y1 is 4 over again this y1 dash, when you solve it, it will be equal to 4 over 75 pi, clear, and the unit will be in meter, and this will be equal to 1 over 25 pi and the unit will be in meter. So y1 is 4 over 75 pi into area. Area for this solid semicircle is or sorry, for this semicircle is pi by 2, because this is semicircle, so it will be pi by 2 r square. So pi by 2 and r is 0.04 square minus y2, which is 1 over 25 pi into area of this semicircle. Clear? And this is equal to pi by 2, 0.03 whole square. So I will write it 0.03 whole square into pi by 2. So when you solve this, you will get Q will be equal to 24.667 into 10 to the power minus 6 cubic meter. Now this is the Q for this portion. Clear? This portion. So this is the value of Q. Now we have Q as well. Clear? We have we do not have I. I can be calculated for circular hollow cylindrical pipe. It is pi by 4 C4 C outer 4. So C outer is 0.04 power 4 minus C inner, which is 0.03 power 4. So when you solve this will be 0.4375 into 10 to the power minus 6 multiplied by pi, and the unit will be in meter power 4. Now you have I as well and T. So T will be thickness over here plus thickness over here. So I will write T is equal to 0.04 minus 0.03 multiplied by 2, because 0.04 minus 0.03 will only give you this thickness. So we have 2 thickness over here, so we'll multiply it with 2. Now you have each and every value. Clear? So you can just put it in the formula, in this formula. So I will put it, tau max is equal to Vmax. Vmax was 20 into 10 to the power 3. I will show you. You can see 20 kilonewton into Q is 24.667 into 10 to the power minus 6 divided by I is 0.4375 into 10 to the power minus 6 multiplied by pi, and thickness is 0.02. So again, when you solve this, you will get maximum shear stress comes out to be 17.9 megapascal. So this was all about problem 7-7. I hope you have enjoyed this video and you have learned from it. Again, those who are new to my channel, then subscribe it and press the bell icon so that you can get notification about my latest video. If you have any question, you can ask me in comment section. Thank you for watching.